There is a lot of misinformation today about the nature of PET and its effect on human beings. PET is a polymer which is essentially made of polyethylene terephthalate, which is produced from two monomers which are the building blocks. When you take these two monomers and put them together and make a long and big molecule, we call it a PET. The two monomers are either dimethyl terephthalate or terephthalic acid and ethylene glycol. When these two react, they form a long chain, we call them a polymer, and in this chain these two chemicals are completely linked in a chemical fashion.
Polyethylene terephthalate is manufactured by industrially on an industrial scale by a reaction known as trans-esterification reaction. Wherein the monomers, the small building blocks like dimethyl terephthalate is reacted with ethylene glycol under in a certain temperature profile. And another route to make polyethylene terephthalate is by a reaction of terephthalic acid, which is another building block, with the same monomer, co-monomer like ethylene glycol. So this is how polyethylene terephthalate is produced on an industrial scale, and the monomers required, like I mentioned, are dimethyl terephthalate, terephthalic acid, and ethylene glycol. To the best of my knowledge, these chemicals are safe to handle, and when the polymerization is done on an industrial scale, the due precaution is taken, to handle these monomers. So I don't see, there is any problem in terms of the safety of these chemicals involved in polyethylene terephthalate manufacture.
A lot of plastic processing techniques have been borrowed from either glass or metal processing techniques. So plastic bottles are made sort of in a similar way as the glass bottles are made, in the sense that both materials are converted into a molten state and then blown. So air is blown into it to make a bottle. With PET, there is a slight improvement that is done in this process, which is that the process is in two steps. So in the first step, what you make is called a preform, where a sort of cylinder of PET is made, and in the process the polymer molecules are stretched a little bit. And then this cylinder, which is called a preform, is then blown in the form of a bottle. And what this two-step process does is that it gives a certain orientation to the polymer molecules, and therefore makes the polymer, gives special properties to the bottle which are hard to find in glass. For example, the PET bottle is very transparent because of this process. The orientation helps in improving the strength of the bottle, but most importantly it helps in preventing the whatever is stored inside, let us say a carbonated soft drink, it reduces to a large extent the carbon dioxide from the liquid to diffuse out into the atmosphere. So the storage life of the material inside is enhanced. So to answer in brief, the process of making PET bottles is sort of borrowed from the glass, but it is then improved significantly to impart special properties to PET.
PET is a material which can be converted into many products, including textiles, fibers, the clothes we wear, and also into bottles, which are transparent materials. Because they are transparent, they are extremely useful in packaging materials. When PET is made and converted into these products, they have been subjected to pretty severe processing conditions, and in spite of it, these molecules are extremely stable. PET as a molecule is very stable. It is hydraulically stable, it is chemically stable, it is stable to biological environment, and nothing happens to PET under most common application conditions. And that's one of the reasons why we drink liters of water from a PET bottle every day. We drink a whole lot of other, we eat and consume a whole lot of other materials like vinegar, tomato ketchup, sauces, salad dressings. All of them are packaged in PET containers, and they are extremely safe.
All of us use plastics every day for many applications. So plastics are really useful materials. Well, compared to the Western or the more developed societies, our per capita consumption of polymers is very, very less, and in fact there is plenty of opportunities to increase use of polymers in variety of applications. Obviously, when we are looking at new materials for new applications, we have to be careful. But fortunately, our polymer industry is quite well developed in a sense. We have very large manufacturers which are, top few manufacturers of plastics in the world, and all the technologies which are required to maintain the quality are already available with us.
PET, because A, it is safe, B, it is lightweight, which means I can carry a lot more material in PET. For the same weight, I can carry more bottles in PET, and that has other repercussions on greenhouse gas emissions while transportation and so on. So it is safe, it's clean, no hazards, and at the same time it has all these other advantages over glass. Carrying 25 liters of water in a glass bottle, in that case the glass probably would weigh more than the water itself, whereas carrying 25 liters of water in a PET bottle would be so much more easier because of the lightweight of the PET bottle.
I think there has been a little bit of a misunderstanding, because in some parts of the world, a plasticizer molecule which is called dioctyl phthalate has been questioned in regard to its safety. The word phthalate there and terephthalate here has kind of given people an impression that that molecule, which is dioctyl phthalate, is present in polyethylene terephthalate. But polyethylene terephthalate does not contain any phthalates. It has what is called dimethyl terephthalate as a building blocks, but even that, once it's polymerized, it is no longer in the same form. And the dioctyl phthalate, which there has been a little bit of a questions regarding its safety, is actually not ever used in PET. It is used in certain applications of PVC. So I think this whole issue of a controversy regarding the safety of PET use, especially in food contact application, is in my opinion misplaced, and I think PET is an extremely safe material.
Many of those heavy metals are not really needed in manufacturing of PET and are not used in PET manufacturing. The only catalyst that is used is antimony, and antimony is used in such low concentrations, and anything that could possibly come out would be way below any limits that regulatory agencies have set.
Catalyst, of course, is used to accelerate the reaction, and it is used in very tiny amounts. I don't think there has been any proven evidence that the catalyst residue cause any harm to the human beings. Sure, under normal conditions, the metal residue will not be leached out.
All polymerization processes which involve linking of monomers require a catalyst. Without a catalyst, you cannot polymerize. So every polymer that we know requires a catalyst. By very nature, the catalyst means it is used in very small quantities. In the case of PET, we use antimony trioxide, Sb2O3, as a catalyst. Now, antimony trioxide is an oxide of antimony. Okay. Now, when you actually mix antimony trioxide with the raw materials, which is dimethyl terephthalate or terephthalic acid and ethylene glycol, it actually forms a complex with ethylene glycol, and then it promotes the polymerization of the dimethyl terephthalate with ethylene glycol. Now, when this polymer grows, it grows into very long chains of very high molecular weight materials. At the end of the reaction, the amount of antimony that is present in that polymer is hardly of a few hundred ppms. Now, given that, that catalyst is now bound very strongly to the polymer. Okay. Now, there is no way this catalyst will leach out into any fluid which is contained in that bottle, because there is no mechanism of such leaching possible for two reasons. Antimony trioxide is now bound intricately into the polymer matrix. It is not easy to take it out from the polymer matrix, and secondly, antimony is in the form of an oxide, which is itself is a bound form, and therefore it's very difficult for it to get out of the system.
PET has there is no additives in PET other than the monomers which have already been converted into a polymer. So once you have the polymer formed, there are no free chemicals in a virgin PET bottle, right? trace amounts of antimony which is used as a catalyst in making PET. A is too small a quantity to leach out, and B, it is very difficult for antimony to leach out easily from PET bottles under normal conditions of usage. So, there are neither free chemicals nor heavy metals that can leach out of PET bottles. So, I do not expect anything to leach out of PET bottles into the liquid that is stored inside.
BPA is a short form for bisphenol A, which is a darling monomer of polymer chemists, and many polymers are produced on industrial scale from BPA. But talking about polyethylene terephthalate, there is no question of BPA getting formed in the transesterification reaction or in the manufacture of PET. So, we cannot relate BPA formation in PET manufacturing. So, the question of hazards associated with BPA do not exist in case of PET.
PET bottles does not need any other additive. In particular, phthalates are normally plasticizers and they are not needed in PET processing at all. So, phthalates is completely out of the question. On the other hand, the other question about whether phthalates can be produced is also very unlikely, and the kind of phthalates which people are worried about as endocrine modulators are never produced from PET.
There is a list of chemicals that are suspected endocrine disruptors. As far as I know, none of the constituents of PET are part of that list of suspected endocrine disruptors. Even after that, there is no chance that anything would degrade under the conditions of processing in terms of small molecular weight organic compounds that will come out into the PET. In fact, tests have been done through various very sophisticated analytical methods to look at what are the volatile gases that are present in the PET, and there is practically none in the case of PET. Therefore, the chances of anything that is degrading and devolatilizing from the bottle is pretty slim. But even though I'm just saying that none of the ingredients that are part of the PET are known to be suspected endocrine disruptors.
There are no phthalates, free phthalates in PET. So, when we say free phthalates, these are small molecules of phthalate esters, monoesters, which are the known endocrine disrupting agents, and in PET there are no such low molecular weight phthalates which are free. Everything is converted into a polymer chain, and so there is no question of any endocrine disruptors like phthalates leaching out from PET, because there are none inside the PET in the first place.
As per our regulatory processes, the regulations have laid out what colors are acceptable for use in different applications, be it food contact applications or pharmaceutical applications. And the pharmaceutical manufacturers or the food processors who are packaging these products are aware of these regulations and are supposed to take care that these regulations are complied with. So, most of these colorants which are used are safe, and typically they have been tested against certain standard testing methods.
The pharmaceutical products which are packed into these bottles, normally before they are approved for such packaging, they must have undergone substantive amount of testing and evaluation. Normally what they do is they subject the material that is packed into these bottles under what is called accelerated conditions of fairly high temperatures, in order to see, even under these accelerated conditions, what is it that comes out of these bottles. There are specific test methods and standards prescribed for these. Under these conditions, it has been proven that even under the most aggressive conditions of leaching and extraction, less than a few parts per billion of antimony actually comes into the contained material. And therefore, but these, mind you, these are done under very aggressive accelerated conditions. Now, you extrapolate the same thing to, let us say, ambient temperatures, or even let us say 40 to 50 degrees centigrade, the chances of any substantial amount of antimony leaching into the formulation is pretty slim.
It is extremely safe to store pharmaceutical formulations in PET bottles at all geographical conditions, right from Rajasthan to the Himalayas. So, there should be no problem in storing any oral formulations. High temperatures, meaning of the order of 50 degrees C or 60 degrees C, I do not expect any reactions of chemicals that might exist in the formulations to react with the PET bottle. So, under those conditions PET is non-reactive. So, under most normal conditions I would definitely say PET is safe, and anything stored inside PET would be safe, water, oral formulations, whatever, even beer. To the best of my knowledge, as far as PET concerned, there is no evidence, that there is no conclusive evidence in the literature that says that a certain cause like an endocrine disruption has been correlated with anything leaching out of a PET bottle. There is absolutely no hard and well proven evidence to this. I would definitely say that there are no hazards in using virgin PET bottles, which is all what the mineral water bottles or oral formulations are packaged in. Even for a large exposure time under very hazardous conditions, as would expect in various parts of this country, I do not expect any risks of storing oral formulations or mineral water in PET bottles.
PET has been used by millions of people for over 50 years in variety of applications. I don't think there is any evidence today to relate any issue regarding human health with the fact that PET was used. Ultimately, in the long run, the cause and effect relationship normally happens over a period of time, and I think we have 50 years of history to prove that there is no demonstrable evidence to show that anything that came out of PET has caused damage to human life.
I think many of the plastics which we have to recycle and reuse. Fortunately, in India, we really have a good recycle rate compared to some of the other parts of the world. And all of these, in fact, because we have the society is structured in such a way that our recycle rate is fortunately very high, and we need to, and all the regulations are already in place, and we hope that because of our high recycle rate, we can really hope to and look forward to increasing use of polymers and better materials.